Hi, today we're doing solving of systems of inequalities by graphing. So we started out this unit by graphing a system of equations, and now we're going to graph a system of inequalities. So let's take a look at a couple examples. First example says, well, first of all, we just need to define a system of linear inequalities. So that's an ordered pair. The first thing I want to do is identify what a solution is to a system of linear inequalities. And just like a solution to a system of equations is that point that makes both equations true, a solution to linear inequalities is an ordered pair that is a solution to both inequalities in the system or all inequalities in the system. So let's take a look at graphing a system of inequalities. Here I have y is less than or equal to 3x plus 2, and y is greater than negative x plus 4. So I have to graph both of those inequalities individually. I'm going to start by graphing the first one, and I will graph it in red. Let's go with red. Okay. So first of all, I'm going to start by y-intercept at 2. And my slope is 3, so up 3 over 1. And I can go down 3 over 1 as well. This one has a solid line because it's less than or equal to. So if I get out my line tool, and I can draw a line through those points. Just like before, you always want to make sure you extend your line all the way through your graph, especially for linear inequalities, because when you shade, you're shading a portion of that graph. Okay, and then I'll go ahead and shade. And voila, it's shaded. Notice that it's shaded into the lower right-hand corner because it needs to be below my line because it's less than or equal to. Now I'm going to go ahead and graph the second equation in blue. So I have y is greater than or equal to negative x plus 4. So my first point goes on the y-intercept, which is 4. And then I go down 1 over 1, down 1 over 1. This time, however, I'm going to have a dashed line. So when I get out my line tool, I have to make sure it's blue and dashed. So then I'm going to go ahead and draw my line right through those points and extend it all the way through the graph. And then I'm going to go ahead and shade. Now I'm going to shade above the line this time because it's greater than. And voila, again, I have the shaded region here. So the next thing I need to do is give a solution and a non-solution. So my solution is this area here where I have the double shaded area. So any point in there is going to be a solution, including this point here that I already have. So I have solution for 4. A non-solution is anything that's not in the double shaded area. Now the other thing to notice is that solutions are not on dashed lines. So for example, if I chose this point that's on this dashed line, the point 4, 0, that's a non-solution because it's on that dashed line, even though it appears like it could be a part of the shaded area. Okay, now I want you to try. Here is your self-check. Go ahead and graph these two lines and check your answer. Please give me one solution and one non-solution. Oh, take a look. There was no solutions. I tricked you. So if you take a look here, we have two parallel lines, and the shading are opposite each other. This one is greater than and this one is less than. Therefore, there's no overlapping of the shading regions, and therefore we have no solutions to this linear system. Let's go ahead and do now one that is a 3 by 3, so 3 linear inequalities. So let's just start by graphing each of them. We'll start with the first one in blue. Okay, so this is an absolute value inequality where I need to figure out my AH and K are. My A here is 2, my H is 0, and my K is 1. So I'm going to start by graphing at H comma K, 0 comma 1. Oops, that is not correct. Okay. Then I'm going to use my slope, up 2 over 1, up 2 over 1, up 2 over 1, go back to my vertex, and then go in the opposite direction. Taking a look at what kind of line I need a dashed line because my symbol is strictly less than. So when I get my line tool out, I need a dashed line, and I would like it to be blue. So there's my absolute value inequality. Now I need to shade it. The shaded region is going to be less than, so it's this less than area. And again, like magic, shading has appeared below my V. So the next one I'm going to graph is x is greater than negative 3, and I'll do that one in red. Okay, so x is greater than negative 3. Well, that's a line through, a vertical line through negative 3. So I'm going to put my point on negative 3 on the x, and then I'm going to grab my line tool. I also need a dashed line here because I have strictly greater than, and then I'm going to go ahead and draw my line. This is x is greater than negative 3, so I'm going to shade to the right of this graph because that's where all x values are greater than negative 3. Okay, now I have my shading done for my red graph, for my red line, which is x is greater than negative 3. The last line I'll do in green, which is y is greater than 1 or equal to 1. So I'm going to go ahead and do that's a horizontal line through the point 1. So I'm going to go ahead and put a point on my graph at 1 for y, and then I'll get out my line tool. This time it has to be a solid line because it's greater than or equal to. So I'm going to go ahead and put a solid line. Right through y equals 1. This one I had to shade above because it's greater than or equal to. And now I have all 3 parts shaded. So now I need to find a solution and a non-solution. And I'm going to look at where there's 3 overlapping of shading. And that portion is right here. Oops. That's not what we want. We want a pen. If you take a look here, right here, it's right here under the V. That's our triple shaded area. That's where it's shaded above y is equal to 1, to the right of x is equal to negative 3, and below the absolute value 2 times the absolute value of x plus 1. So I can pick any point in here to be a solution. And I'll go ahead and pick this one. This is the point 5, 4. A non-solution is somewhere that's in a non-shaded area. So perhaps I would choose this point right here, 6, negative 6. Even though it's in a shaded area for 2 of the graphs, it's not a solution to all 3. Okay, go ahead and try the next one. Here you have a system of 3 inequalities. Shade each region, and then give me a solution and a non-solution for that shaded area. Okay, there you go. Here's my example of a solution, the point 0, 1, and a non-solution, negative 2, negative 5. Right there. Okay, the last thing we're going to do today is write an equation, or write a system of inequalities based on the graph. So here I have a graph of 3 inequalities, and they're represented by blue, green, and red graphs. So I'm going to go ahead and do them in their corresponding color. So let's start with blue. And it looks like blue is a horizontal line through the point y equals 4. So if I write that out, I would say this is a horizontal line, so it's y is equal to 4, but now I have to create a new symbol instead of equals so that it is an inequality. Well, it appears that the graph is shaded below because I can see that there's some blue shading right here. And it has a solid line, so this is going to be less than or equal to 4. The next one I'll do is the red line, and this red line is this dash point one here. It starts at a y-intercept of 2, and then it goes up 2 and over 1. So this is a y equals 2x plus 2. Now I got to figure out my symbol instead of an equal sign. So here I have a dashed line, so it's definitely going to be greater than or just less than. And it seems that my red shading is off to the side here, which is a greater than my graph. So this is going to be, go ahead and write y is greater than, because that shading is done above the graph. The last one is my blue line, and, not my blue line, my green line. And my green line is a vertical line to the point x is equal to -2. So just like before, I have what I would normally write as my equation, but now I'm going to change it, my symbol, based on my line and my shading. My line is solid, so it's going to be greater than or equal to or less than or equal to, and my shading is done to the right of the graph. Well, my x values to the right of the graph are greater than x, so this is going to be greater than or equal to. So writing a system of inequalities based on a graph is basically just analyzing each thing individually to figure out how to write that system. Okay, last check. Go ahead and see if you can write this system of inequalities yourself. Go ahead and check your answer. We will continue to work with systems of inequalities tomorrow in class. If you have any questions before that, please see me. Have a great night.